Good evening, participants. Today, welcome to the fifth day of Atal FDP 4.0. So today our guest is Sri P.L.N. Raju Garu, Director, Assam State Space Application Center. So he has done his BE Civil Engineering from Mysore University in 1984 and MTech in Remote Sensing from Anna University in 1987. He is also former head of the department, PPEG department, Indian Institute of Remote Sensing, ISRO. He is also former director, Northeastern Space Application Center, Meghalaya. Sri P.L.N. Raju Garu is the present director of Assam State Space Application Center, where he leads initiatives to promote space technologies applications for regional development. He collaborates with government agencies and ISRO to advance projects in remote sensing, satellite communication, and GIS, supporting sustainable development efforts in Assam. His work focuses on leverages space-based technologies for environmental management, disaster mitigation, and resource planning. Now I present Sri P.L.N. Raju Garu. So hand over the session to Sir. Sir, you may start, sir.
Yeah, good evening to all of the participants. So I'll be going to talk on LiDAR technology and applications, mainly for the civil engineering side, and as well as maybe some other applications as a general. Just a minute, my power disconnected. Just a minute. इसका स्विच ऑफ हो गया क्या? हाँ सर, इसका ऑन कर लो। वो पीछे से आता है वो सर। पीछे से आता है इसलिए। हाँ पीछे से। अरे कभी बहुत साथ हुई। ऑफ। नहीं आ रहा। Okay, thank you. Yeah, good evening, all of you. There was a disconnection of the power in between. I'll share my screen. Yeah, you're able to see my screen?
Yes, sir. Yes.
So I request the participants, any questions in between, they can also ask me. Maybe continuously speaking, I'm not able to know that whether people are able to understand or they are attentive. So request them anytime, they can also raise questions and ask in between. As I seen that program is basically use of the technology of different various technologies for civil engineering site. But I also seen one talk on a geospatial visualization related to satellite data, other thing that was also one of the topics. And then my focus is on LiDAR, basically light detection and ranging. Before that, I just wanted to also inform that maybe you are also aware, to participant also aware, there are various technologies are available as far as similar to LiDAR technology is concerned. LiDAR is basically the two types. One is you collect the information from the ground on a discrete manner. Another is a continuous. In case of the discrete means you collect the data point by point. So as a civil engineer and planner and then execution of something on the ground, we take the measurements. So these measurements can be in a room. Suppose if there is a room of some size, suppose if you want to plan something in the room and design something for the walls and ceilings, etc. So first of all, we measure the size of the room. So measuring is olden days we used to measure maybe the tapes, etc. But now these whoever is the engineer planner, what they do is they just take the laser pointer and put it on the one side of the wall, and then laser gun is pointed to other side of the wall. So then the laser beam goes from one side to other side, and then digital display it will show this is the distance. So the distance is basically finding the how much time it is taken and come back, and then it calculates complete which means what is this thing. Another is a continuous observation, that is a continuous waveform. This is suppose if you are observing something trees from the above the trees and front of the trees, etc. So then we sent in a waveform and then it observe, and then it also says the properties of the type of the trees there, and then quantity or volume of these trees. So basically for estimating the biomass, etc. This is one slide I kept. This is based on my understanding. So you use this one, use of the BIM, Building Information Management software. So any planning is done or any before construction, basically any planning for the building. It is a small individual building or a bigger structure or is a group of buildings. So this is it is used. And then another is rainfall assessment and prediction. This is basically normally we use the equipment, but this can be also done in a satellite based. Having a satellites, so their satellites also collect the this data, and also from the ground instruments. What we do is AWS or rain stations, and then flood studies. What is that? We use like a microwave satellite data to, or otherwise optical also. But normally, whenever there is a flood is there, so there are clouds are also associated. But in that case, the satellite cannot provide the ground coverage and the extent of the floods. For that, we use a microwave, though it penetrates through the clouds and collect the data. So flood studies includes flood dynamics, and then it also integrating with the your ground information, like where are the buildings are there, where are the crops are there, where are the trees and where are the livestock. So various information which are there on the ground, if the GIS information is generated, so that will also tell you that this much of the settlements or houses are inundated, etc., and then how many houses are damaged. So the satellite data will help. Similarly, there is, if you talk about major reservoirs, rivers, like a Krishna River, Godavari River, Ganga River, and in case of Northeast, this is a Brahmaputra River, etc. So they have an embankment of almost 1,000 kilometers embankment, so that whenever this river water rises so that the embankments protect them. But if they reach beyond the danger mark, so they will also breach out and then the flooding. So knowing the embankment, it is in terms of the structure, in terms of the strength of the embankment, etc. So this is also, we can, LiDAR can also play important role in that. So another is river valley projects and all these things, Damodara Valley Corporation, Nagarjuna Sagar, etc. If you wanted to have a detailed investigation, civil engineers only plays an important role for them. Having this detailed investigation in terms of the different type of features they are there, and in terms of the land use, land cover, and also topographical information, this LiDAR also plays very important role in that. Land use, land cover information, high resolution satellite data will help. Drainage network analysis, topographic information, that also. Topographic information we generate based on a three-dimensional information that we do with a photogrammic technique, or otherwise a LiDAR, it will both will help. Water resource assessment is a total water balance studies. We can use the rainfall, this station satellite-based information. Data also can also use topographic information, overall assessment of what is the rainwater, annual rainwater, etc. So total water budgeting, etc. All these things can be done. Water quality studies. LiDAR, I'm not sure that water quality studies, but if you talk about optical remote sensing and also that they will help in water quality. Watershed delineation, whether you derive from LiDAR or microwave, interferometric microwave, or stereoscopic photogrammetric studies, or even drone-based, these things all will help. Watershed prioritization means knowing what is the condition of the this watershed, which watershed is more prone to soil erosion, is less vegetative cover. It is causing soil, taking out soil, and then also silting the reservoir. So these are also watershed prioritization will help. Similarly, soil loss assessment, all these things. So then we also generate a DEM, DSM, DTM using the different techniques using LiDAR. हमारा निकल गया. I'm sorry. I'm in a hall where the program was going on, so they are removing the cables and causing problems. So there are other things like I have listed all other things. So there are different type of technologies like you are able to hear?
Sir, yes, sir.
Okay, okay. So there are different satellites. Orientation is also important role. Suppose when you talk about urban planning and smart city, so where you wanted information about the terrain is one component, and you also information about the tall rise buildings. Suppose if you wanted to know what is the height of the building, another is if you wanted to know that what is the type of building it is. It is a government building, residential building, flat systems. So there is a different architectural design what you see on the roadside, big tall buildings. So if you go to the Hyderabad and you see Microsoft and you see all Google offices, so they have different tall buildings. So if you wanted to take that and also fix everything as is there on the ground. So then you require to take this thing using the oblique angle. So for that, so that you create a three-dimensional virtual creation or those things. For that, you have to capture that in an oblique view. So that there is sometimes like they keep 5 cameras for these. Either you talk about the drones or you talk about the high resolution satellites. So they have a front and back and the two sideways and with the different angles. It can also go up to 45 degrees and take a multiple collection of the data so that you recreate the total this thing on the ground as it is, particularly for this is for the urban areas and smart city planning. And then optical remote sensing, there are many satellites are there using Indian remote sensing satellites and commercial satellite. I wanted to ask from the participants also. You know that there are optical remote sensing satellites. You know at what resolution these satellites provides the data? Anybody can say? Do the participant know that what are the remote sensing satellites? Somebody can answer. Any response from the participants?
Also,
You're able, yeah. Any response? Now, what is the difference between?
Is it 1 meter,
yeah.
sir?
Yeah, 1 meter. But you know any satellite of 1 meter?
No, sir.
You see, if you talk about what is your background?
I am a civilian. I'm Professor Jagannath Rao from Chaitanya Bharat Institute of Technology.
Okay. So you are not aware of different type of satellites, is it?
I know about the satellites, but which is what accuracy, these details I am not aware, sir. I'm not into that. I'm a structural engineer, basically.
Oh, okay. See, basically, when you talk about a smart city planning, etc., and urban planning, and then if you wanted to develop a new city like Amravati city, etc., so because everything new and then plain areas. So which are the commercial areas, which are the residential areas, which is the industrial area, which is the schooling, parking, all these things. If you wanted to have a planning, so then you do it on the ground. So it takes a lot of time and investment. The same thing also can be done using this planning using the satellite data. So for that, if you wanted to have a detailed investigation, and you have to acquire the satellite data. So these satellite data comes like 30 centimeters. People are also talking 25 centimeters. If you talk about military and all, so they talk 15 centimeters. So that means whichever is there on the ground of 30 centimeters, that we can see at the satellite. So that means each 30 centimeter become a 1 pixel on the satellite image. And then if there is a car is there or the individual is walking, all these things we can also identify on this. Suppose there is a stream is there or there is a hillock is there and agriculture field is there. All those things to identify these things. So we require a satellite data, and then it is easy and quickly we can do that. And if you talk about our own satellite system, we have a Cartosat 3. So that is the satellite which is there. So which is around 30 centimeter, 25, 28 centimeter. That is the resolution of So that satellite. And similarly, there are resource sat is there, which is of 5.8 meter resolution. And there is also there are other satellites are also there, like a commercial satellites. They're all private company owned satellites. And Indian government also going to launch a constellation satellite from the private company. So if you see all these things, I can say there are around 400, 500 satellites related to all these remote sensing, microwave. These are all the satellites are there. So they all help us in getting the data on a high resolution to medium resolution and coarse resolution. High resolution, what I mean is 1 meter or less, or you talk about a 50 centimeter, 30 centimeter, and medium resolution, something like a 5 meters, and coarse resolution around 25 meters, etc. So, and then we have other satellites like these satellites, anybody in the participant, they can guess what is the height of these satellites? Somebody?
Sir, above 1500 kilometers.
1600.
Yes, sir.
See, these satellites are divided into 3 categories: low Earth orbit, medium Earth orbit, and high Earth orbit. So LEO, MEO, and GEO we call. So LEO orbits are basically, you all know that Shubhanshu Sharma now, who has gone to International Space Station. So you know that what is the height of that International Space Station?
Around 900 kilometers, I think so.
No, you are wrong. So it is around 300 kilometer range, 300, 400 kilometer, 350, 400 kilometer range. So this they go very low Earth orbit. But if you come to remote sensing, what I am talking, so they are of I can say 500 to 700 kilometer range. So these are all. If you talk about any satellite which is sun synchronous, so they are all basically placed at the 700 to 900. So you can say, as you mentioned, 900, it is not for Earth, this one, International Space Station, but it is for the remote sensing, it is 900. And if you if you go to GPS, GNSS satellites, so they are there 36,000 kilometers. So that means I am talking about a low Earth orbit around 1,000 kilometers. And then GPS satellites, I'm talking about around 20,000 kilometers height. There is a GPS is there. There is a GLONASS from Russia is there. Our Navik is there from India. So, and there is a GLONASS from the Russia, GPS from USA. So these are all basically provide the solution. So similarly, as a civil engineer, we also use a total station to detail investigation on the ground. So these are the different technologies what we use, and then they are also useful for the civil engineering purpose. But our focus today is more on the LiDAR remote sensing. So these LiDAR can be aerial, satellite, UAV, drone, and then ground-based. So ground-based, these are all called the terrestrial lasers. And the UAV, everybody knows about UAV and drones. So these UAV drones comes for the different purposes. So one is you talk about a agri drones where they spray the pesticides. So they go all along the ground, just 5 meters above the ground and above these crops, etc. But if you wanted to have a mapping of something, then we go 60 meter is the minimum to 120 meters, and you can fly up to 300 meters. So these are all mapping drones. So mapping also, you can put a sensor. So the sensors is like RGB camera, like what we use in your mobile, or you use a multispectral cameras. So people, anybody know what is multispectral?
No,
Anybody? So
No.
one is one we say RGB camera. It is a single band camera, combination of all collecting the in color. So then once if you talk about a electromagnetic spectrum, it will having the spectral range starting from the visible spectrum. Then we have a near infrared spectrum, and we have also thermal infrared, and then we have a microwave, etc. So each spectrum or each what we do is we put a sensor in the satellites. So that means we divide the whole electromagnetic spectrum into different discrete regions. So I say blue region, green region, red region, etc. So then we collect the data in each spectrum. So that is called a multispectral. So that means if you talk about a satellite, multispectral satellite, there will be 4 or 6 band combinations will be there. If you talk about a resource sat, we have a 4 spectral bands. Normally, we'll have a blue, green, red, and near infrared. So there is a thermal infrared and shortwave infrared. So these are all put into one camera and collected in different bands. Suppose if you talk about a one picture you collect with your mobile, same thing if you have a 5 spectral band means same area we collected in the different regions in the 5 regions. So these are all called a multispectral satellite. So when we make a combination, suppose if you see the Google Earth, so there we see in a vegetation is seen in a green color and water is seen in a blue color. All these things because of it is generated in normal color. If you talk about a false color composite, what we generate red is basically vegetation, etc. So one we say when we say that high resolution data where 1 meter resolution, that it is collected in one band, that panchromatic band. So it is collected in the complete visible range spectrum, 0.4 to 0.9 or 0.7. So that is collected. So in the drone also, we use all these things. We use a panchromatic, we use a multispectral, and also we use a LiDAR, means laser sensor. And also we use a microwave sensors. So when you come to this sensing, LiDAR is something like it is basically in a visible spectrum. Either it can be a green or infrared laser. So you send the signal and receive it. So these are all some of the questions. So then if you know that answer this thing, you'll also have a better understanding of what is the LiDAR. So somebody can say what is remote sensing? Anybody have idea?
Without a physical contact, acquiring the information from the far area.
Yeah, great. So that we do it at different levels. Either you do low Earth orbit or medium Earth, etc. So in case of all these things, we collect it sun as a source. Means the light is illuminated on the ground, and that illuminated light is backscattered and then collected by these sensors. Either it is a multispectral sensor or it is a near infrared, etc. So that is called a passive remote sensing. That means I am not putting any energy to get it eliminated. Suppose if there is a satellite is rotating around the Earth, and then it is in front of India and it is collecting the data, but the satellite goes from the north to south and it is a sun synchronous. So in that case, what happens is when it collects off of the Earth, where the sun is illuminated, when it goes to the other side, it will be night, so the dark side, so that it will not able to collect the data. But if the same thing you have a microwave or you put a LiDAR sensor on that, so basically it is sending its own source of energy, hitting the target, and the return it is capturing. So in case of a microwave, backscattered energy, in case of a LiDAR, whatever is a point, it is sending, and then whatever response comes, again its sensor collects again. So that means it is an active sensor. So that means the LiDAR is an active remote sensing, whereas other like many satellites, what I'm telling is, so these are all optical remote sensing satellites. There are many satellites optical, but not LiDAR in the orbit. So what is the reason for not having the LiDAR satellites in the orbit is so because you require a high energy source to be sent and collected. So these LiDAR remote sensing, if you compare to normal other optical remote sensing or passive remote sensing, very few satellites were there. In 2004, there is a one satellite, and recently there are 2-3 satellites are launched. So where you require a high energy power, so to operate these things. So that is one of the reason having a, and then technology wise, if you see that earlier GPS was not there, a precise GPS. So because of that, because we have to understand the LiDAR. LiDAR is a detection, light detection and ranging, but at the same time, getting the information in a point wise and waveform wise, but it is specific to particular location. If you wanted a location information more accurately, so you should also have that its positional information more accurately. So these GPS and GNSS systems, they have evolved over the time. So now we are talking about getting the position in meters and centimeters by the GPS. The same thing is integrated with the platforms so that when you generate a profile, the profile is coming, but at the same time, it should belong to the area where it is coming. So that is the reason where these they are not well developed compared to the optical and passive remote sensing earlier. What is the source energy coming for capturing the light? It is sending a beam and collecting. That is the source. This collection of data is the same or different in case of LiDAR as compared to the normal remote sensing. Yeah, it is entirely different. It is, we are not doing the this thing. When you talk about optical remote sensing, so there what we are doing is we are capturing the full frame pixel by pixel. So that means we collect the data continuously there, but whereas in case of LiDAR, we send a signal, a particular point or a particular smaller area, maybe 10, it is 100 square meter area or 150 square meter area. Or in case of aerial, it is a point profile we collect. LiDAR data different from the P.L.N multispectral. I already explained. What is the satellite that works on the laser? So what is the discrete? There are you collect the information for whole area. That is a continuous phenomenon. You collect. So there is a if you collect the whole area, that is a continuous phenomena area. If you collect for the particular point, so that is called a discrete information. So any specific question from anybody?
No, sir.
Are the participants are able to follow what I am telling?
Yeah, we are following,
Well,
sir.
yes, we are following, but we are not basically we are civil engineering side. So that's why we are understanding what we are telling. We are not able to ask questions.
Correct. What I wanted is maybe you raise your questions, so then I can answer also. That is more better because.
Okay.
So see, when we talk about collection of the information, anybody can stop me in between and ask. I'll try to answer those things. So see, one is I already mentioned that image-based technique like a satellites, aerial. See, I did not mention about one thing. Satellites is collecting the data from the top. Means you are see on the top. You go high and high, you cover the more area. Aerial is something like we all fly in aircraft. So we fly at 10 kilometer or 10,000 meters. But whereas we collect the data, these aircraft, they fly at 3 kilometer range. And if you
At
talk
single
about,
time, how much area they cover, sir?
pardon,
At an instant.
how much area single
A
spot
single
it collects?
instant, how much? Yes.
No, it also you understand this thing. One is you have a camera, you have your own mobile, and then you wanted to capture your group of the people, and then what you do if the group is 100, you go back further distance. If you want to capture only 3 people, so then you come nearer. So that means you come more nearer, so your area is reducing. So if you go further, area is increasing. This is
Now,
one way. Other way,
the satellites, how much they up and down they can move?
see what we call it as these satellites are fixed at one orbit.
Yes.
So that means whatever the data to be collected, it is all pre-planned. Suppose if I wanted the spatial resolution of 50 centimeter, then I pre-plan that what is that my sensor has to be there. If you talk about a satellite, so if I fly at 500 kilometers, the area coverage is maybe 20 kilometer by 20 kilometer or 10 kilometer by 10 kilometer. But if I wanted to have a resolution of 50 centimeters, so if I fly at this height, what is my lens has to be there? What is my focal length? So you increase the focal length, your spatial resolution increases.
Okay, sir.
So
Thank you.
these are all based on the lens assembly, lens and mirrors. Sometimes you create a bigger focal length even in a smaller instrument, but you can also do a tele lens. So that you get a higher resolution. All these things are pre-planned before the satellite is launched. Similarly, at the aircraft also. So in case of drones also, it is because you know the sensor at which you are going to fly. So these drones, what happens is you do flight planning. You say that this is my area of total area I have to map, and this is my spatial resolution I have to keep. I wanted to take it at 5 centimeters. So then it will also tell that you fly at 120 meters or you fly at 60 meters. So you do flight planning and you capture the data, the specific resolution at which you wanted to collect. Similarly, there is a one more sensor is you do it on a terrestrial. Suppose you talk about a big factory is there. If you wanted to make complete machinery, operation, services and maintenance in 3-dimensional model, so then you have to scan through that whole machinery using a laser gun or a laser instrument. So then you recreate total 3-dimensional things and then machinery, equipment, all these things. So then you basically and that use it for this thing. So there you also use the laser. So you know autonomous vehicle. What is autonomous car? Anybody? I think this nowadays everybody knows.
Self-driving.
Driving vehicle.
Correct, self-driving vehicles. So there, what is there is there. What are the instrument sensors are there? What instrument sensors will be there in that? Hello. How this autonomous vehicle works? So these are all laser.
It has sensors on top, sir. What I saw in this
Please.
Google and this Tesla vehicles, they have sensors at top.
What they have?
I think they have
Sensor.
a predefined data they will include in the map. So based on the distance, they will travel that. I think so.
No.
The
See,
predefined data is stored in that.
I saw one Google vehicle in US. One circular rotation will be there on top of the car. It rotates and it observes nearby things. They are
See,
taxi.
one is we talk about a
GPS is the main thing.
yeah, GPS is location. Another is it also having all the type of sensors. See
Yeah.
what see one is you have your own eyes and you have your own hands and you have your own legs when you have to drive. So they have to recreate all these things. Sensors will basically seeing the things, and also it is done on a real time basis. One is what somebody was mentioning is having the data, that data they can put into that. Suppose you have a Google Maps, you put into your this thing system, three-dimensional terrain information here, it is all integrated. That will help you to the nature, what it is, what is the road network, what is the road it is going, etc. Suppose Google Maps, suppose you are going from one place to another place, this road network already there that you are putting into the your mobile, and then it will guiding you, navigating you from place to place because on the based on this. But it is also taking information, real time information, and also these actuators which are all applying brakes or speeding up, all these things that systems are also integrated with this, so they will do this. So when we go on the ground, it will collect the information and also what it is. Suppose there is a person walking in front of a car, so that means the car understands that it is the person is walking. That means he will take time to cross. Suppose if there is a vehicle is crossing, car is crossing, truck is crossing, so it will also identify not only the features, the characteristics of the features, the speed of those things at which they move. Normally, if somebody comes crossing pedestrian crossing, you make it dead slow. But if the car is moving, you know that it goes faster to cross that. So then you apply your own intelligence and then you drive that. Similarly, all these mechanisms are kept in this. So what I wanted to tell is here also LiDAR technology is applied. So in addition to the cars, there are also terrestrial lasers. Terrestrial laser means it is also something like a survey equipment, and then it rotates 360 degrees, and it also collects continuous this thing. So the range can be maybe 600 meters in front of it, or you talk about a 1 kilometer or 1.2 kilometers. So that is the range. But at the same time, in a second, they collect millions of points, and it also capture that three-dimensional profile of that. So it can be used for archaeological monuments and making the this thing record of all the monuments, what is the present condition, if there are any cracks are there, what is the maintenance is required. Or you talk about the bridges, what is the status of the condition of the bridges. Or if you wanted to know something like transmission lines, where this transmission lines, if you wanted to collect the data, where aerial LiDAR is used. But terrestrial laser, if you wanted to work out earthworks, or you talk about machinery, operation services, complete industry, this one, any related to any machinery, all those things, this terrestrial laser is basically is going to help. Or if you wanted to have a design something, so the laser exists. There is a three-dimensional structure. Something is there equipment. If you wanted to recreate and duplicate and modify those things, you basically generate a three-dimensional profile, bring it to the computer and modify and redesign the things. All those things, this LiDAR profiling from the terrestrial camera, it is going to work. Shall I go ahead?
Yes, sir. Go on.
See, this is basically, if you see that it is an active remote sensing sensor as a this thing. It measures. I'll go quickly here. So what I mentioned is it can be done on day and night, because It doesn't require any source, so it is having its own source. So anybody knows that what is DEM and DTM?
Digital surface model and digital elevation model.
Correct, correct. And another is digital terrain model. See, suppose I fly over the area. It is mixture of the ground, mixture of the buildings, mixture of the trees. So if you have, when I fly that area, it collects all the information and then give the height information of the ground and then also height of the buildings, height of the trees. So that is called a digital terrain model. And then because all the places this LiDAR point is hitting and coming back. So that means it will hit on the tree, it will hit on the telephone pole, it will hit on the transmission line. So you remove all other things other than which is hitting the terrain. So that then it generates a digital elevation model. So if you talk about civil engineers, there are structural engineer, I cannot say anything, but the people are working on the ground, designing and then terrain analysis, watershed studies. So for that you require this DEM, DTM is very much useful. So this can help us to find out the slopes, help us to find out the runoff, and then it will also help you to that what is the discharge coming from one place to other place. And then also this terrain will also help us to simulate what is the volume of water is coming to the mainstream. If there is a rainfall is happening over 100 square kilometer area or 500 kilometer area, and then downstream it is something like a 10 kilometer, 20 kilometer, 100 kilometer on the downstream. If there is a floodplain is there, so then how much time it takes the water to reach that place and at what quantity. If the quantity is beyond that capacity of the stream or this thing, so then it will overflow and then create the flooding. So this simulation modeling, once we wanted to do, so for that this LiDAR data, whatever is collected, so you don't require to collect every day. So for generating a profile of the ground, terrain, topography, etc., once you collect, that can be used for even for some years, some these things. So this is the main input for simulation of flood inundation. So similarly, so once you simulate, you will also know that because of this condition, it is going to inundate. So that means we can also do some modeling and predict what is going to happen this time. Suppose in case of Assam, that Brahmaputra river, all along the river, flood is a very frequent phenomena. But the water is coming from Arunachal, water is coming from Bhutan, water is coming from the China. So only I think 45% of the catchment is in India. It is one of the biggest catchment for the basin, and then 55 catchment is in China and Bhutan. Another important thing is these, in case of a optical and the normal camera, you capture something, so it captures in one snapshot. But this is not the case in case of the laser scanner. Suppose laser these things. Suppose it comes at different intervals. So first it comes from the canopy and the middle of this thing, and then it comes from the ground. So that means you will get a multiple returns. So you have to understand optical remote sensing. It is one at a time you capture everything. In case of microwave and then LiDAR, so you will get a multiple returns. So those returns will help us to identify either tree structure, type of the tree it is, and then finding out the volume. Similarly, creating the terrain profile. There is a DEM, DTM, etc. So as I mentioned, if you do it in a point wise, so suppose if I say 1 meter ground this thing, you collect the data. So there may be 100 these things returns come. So that means 100 meters. If you have 100 these things, so that means at each meter, if you talk about this thing, there is a return is coming. So that means 100 by 100, it is called 10,000 returns. You get returns. So that means you have 10,000 locations. You have a profile generation. Height it will generate and give it to you. So there are different these things. Type of LiDAR. So this is something like a terrestrial LiDAR it is. This is a drone LiDAR. This is also a drone. And then this is a glass. This is a satellite, this thing, geoscience laser altimeter system. And then there is a vehicle-based tracking. How many of you seen Google Street View? Anybody has seen Google Street View?
Yes, sir. Yes, sir.
What we get there?
We get a 3D image of the whole street, sir.
Correct. We will get a walkthrough this
Walk
thing
through
view. Suppose you are going in a vehicle and then you put that Google Street, it will exactly show that what you are seeing with your eye, and same thing it will also show is a particular location. It really help for the people to easily reach the place without any guidance support. And then what is that? If you talk about a Google this thing, suppose you open your mobile, so it will say that this is this direction and this thing. So the live information also it shows. So I don't know how many of you understand a digital twin. Digital twin, anybody know? Yes or no? Heard about digital twin?
No, sir.
Digital twin is new technology now. Basically, as a civil engineer, we do a lot of simulation studies. Okay. Similarly, anything if you wanted to make a rocket or if you want to make an aircraft, or you wanted to design a building or architectural planning, etc., or you wanted to do something dam construction, reservoir simulation, so that putting a dam at a certain height, and then you put a terrain conditions, because already you know that topography, DEM of that, and then you put a barrier like a dam, and then how much capacity of water it is going to store, what is the inundation. This you all understand. This is called a simulation. Another thing is that you see that simulation convert into real, and a real conditions. Suppose my dam is there already, my reservoir is already filled, and then how much is the force is applied to the dam because of this water or a silt load, whatever is coming. So that means I am also adding those components to my reservoir. Already I simulated, I constructed. I have a digitally created, simulated the complete thing. And then I'm also adding that how much forces they are hitting the dam. So that means I am putting sensors to that. So all these sensors, they can measure that how much load sensors, and then if there are because of the load increasing on the dam, so the dam try to maybe deflect. So this deflection of this dam is also measured using the laser beams. So there is a laser instrument, terrestrial instrument kept in front of this thing, and there are fixed points on the dam. They fix the points like mirrors. They fix it using that mirrors, and then this laser instrument. It continuously operates this. What is that? Either it is a deflection or is a crack is there. All these things and minor details, if you wanted to do it, you use laser one point. Another is all the sensors, what you try to measure. Some IoT, you heard about IoTs? Yes or no? Anybody? Anybody about IoTs?
Yes, sir.
Yeah, you know what is IoT?
Internet
Yes
of
or
things.
yeah, Internet of Things. But
IoT, Internet of Things.
uh,
Internet of Thinking.
Internet of Things. So it is basically the devices. One is you keep the instruments which we measure that what is the physical measurements on the dam or on the reservoir or anything on the human being, on the machinery. All these things we put, and you collect that information. So that means I collect information about the this thing, temperature, humidity, wind, the load on the reservoir, this one dam, and then there is a laser things are also measuring, there are cracks are developing. So whatever you do in a real time on the ground, physically, it is done on the digital environment. So if your car is running, so after some time it requires maintenance. So then car is running, you're also measuring all this wear and tear off of all these things, machinery, equipment, heat generation, all these things you are bringing into the computer environment. That means all physical things are also, you're not only simulating. So all these things we are converting to digital twin. So to digital twin to work, all this sensor network to be connected to your digital twin. So that means whatever is data collected there, it is coming to your this digital twin environment. So that you know in real time all these things. And then it will help you to preventive maintenance and then performance of anything, whatever is happening. So it is also used for even medical field also. If somebody has to operate heart, so then he has to know that what has to be cut and what is not. Everything he can do in a virtual environment. Understand well how much has to be cut. All these things comes into digital twin environment. So these are all about LiDAR platforms. What we are talking about ground platforms, so we are talking about drone and satellite platforms. So LiDAR operating is basically you send the signal and receive the signal, and then based on the strength of the signal, you'll also know. Sometimes you'll also find out the properties of that in the waveform, etc. So this is where you send your signal, and then you get the return. And then basically, I think people, civil engineers should know what is EDM. EDM, you know? Somebody?
Electronic distance measuring devices.
Correct. So this is also used for the surveying. So similarly, the same concept, it also having a laser. In case of this, what we are doing is, we are not collecting, we are collecting with a mirror, because I wanted to know other side, what is that other side? Because you are keeping a mirror and collecting. And then one is, another is total station, you all understand. There it also works the similar this thing. But nowadays, to reduce the manpower load, one person also can do this total station work. How it works is, it is called a robotic total station. So that means the instrument is there, person carries with that mirror equipment, keeps at every location, and then this lens from the total station, it automatically rotates where you place that. Then you collect the data. So D is equal to T by 2 into the time taken for the light to transfer. So this is also, one is the transmitter, reflector, and then what is the amplitude you collect. So this is what we collect on continuous basis, and then that information is collected. So there are various components in that. One is a laser scanner, which is there. So laser light, it is what we send and receive. Another is a GPS is very important component here. Position, as you mentioned earlier. Third is inertial measurement unit. So it basically your instruments, the whatever sensor, the movement of the sensor, it is how it is moving. It is moving, what is the pitch, row, and all, whether it is tilting forward, backward, sidewards, and it is rotating. So those are all three components are called pitch, row, and it is components. And then computing technology, the precise location based on this collected data, it will also calculate, and using the computing technology, it will also generate a three-dimensional point cloud of that. So these are all basic components what we have here in case of this LiDAR. So one, you have a DGPS controller and data recording, inertial system, ranging unit, laser, and then reflection unit. So based on whatever is you collected from the ground. So this is also collected from the aerial, these things. So if you know the position of the aircraft, so then we know the velocity of that, and then pitch and row, which is the way it is working, and then range, and at what angle. Suppose I talked about I take one point, but at the same time I take different angles. So this based on the angles also, it will calculate the range and distances. So this, if you see this, it is collecting the profile of the ground. And depending upon the height of that, we are generating into different features. So if it is a ground, basically they kept a blue color, and then green, maybe crops. And then if you come to higher level, maybe the top of the trees or hills, etc. So this way it works in the laser. So it will collect the points at various levels: top of the tree, middle of the tree, below the tree. What we get. See, there are cameras, even drone cameras with the LiDAR. There is a 3 written drones and then 5 written. Means the drone having a sensor which can collect up to 3 returns. When the beam is sent, it sends only 3 returns. It collects only 3 returns. The advanced drone is, it also collects up to 5 returns. So like that, we collect the information and analyze the data. If you see this, so it is, so red is the first return. So that means nearest point it collects. Middle is the middle of the tree, and then third is touching the ground. So like this profile is generated. So green means ground information. So red here, it is collected from the between response, and then red is the immediate response, or one first response. So even it is a ground, there is no in between. So there is it is also first response. The second response is this green, etc. So basically, if you talk about the applications, so it is basically it can be used for many applications. One is a generation of a DM. Basically, compared to all others, if you talk about a satellite-based photogrammetry, microwave-based interferometry, among all those things, LiDAR is the best and then give the highest accurate these things. If you talk about NRSC, they give a Cartosat stereo data. Means there is a satellite, optical satellite, you recreate a three-dimensional, and that three-dimensional basically you are creating, and then that resolution, you know how much it is. They say 8 to 10 meters. So that means at one point the accuracy is 10 meters. So when we are talking about LiDAR, we are talking about centimeter. So that is a precise accuracy what we get in this. And then one is you talk about absolute accuracy and then the relative accuracy. I don't know how many of you are aware of the course network, CORS. Just note down and Google it. So this course is continuous operating reference system. So there are 1,000 locations these GPS instrument they installed, and they work 24/7 and all 365 days and continuously observe what is the position of that point. So these are all called control points. You might have heard about GCPs. So these control point, and you use a your GPS rover, and you go around the particular area, collect the data, and take this course information, integrate with your these things. Survey of India allow to take this data to be collected combinedly, so that when you process the data, then your accuracy, positional accuracy, you get high positional accuracy. But what I'm telling that is based on the GPS. So GPS, that means you have to go every place, collect the data. So that is a very tough task. Another is use that also you can do it. If you wanted to do some detailed investigation on the ground, if you wanted to, your campus has to be developed with multiple buildings and then different type of things, parks, etc., playing areas. So everything you, if you wanted to do that, this LiDAR can also help. For that, not LiDAR, even your GPS also you can use, or otherwise fly the LiDAR drone and collect the data. So basically, once you know that it can be used for watershed development, watershed prioritization, and then you talk about what we talk about Ahmedabad and Mumbai bullet train. So for this LiDAR flying is done that area, complete flying, site investigation, and then route alignment. What is route alignment to be done? What is the cutting and filling? So all these things, basically LiDAR is that what we use there. So similarly, there are power line. Suppose the power line is sagging and then touching the trees in between, and then there will be a short circuit, other things happen. So how much is the tree where it is going to touch? If you wanted to have a trimming of those things, this power line, this thing, and pipeline leakages, so we can use this thing. And mining activities, it is used extensively. If you collect the mining, you dump the waste, and then you pile it. After some time, it will started to sliding back. So what is the stability of the this piling of dumps? At what slope you can store it without keep it without sliding? All these things you require a continuous observation. So these LiDAR based things are also it works. If I wanted to know what is the biomass estimation, forest, these things, and then carbon stock estimation, the huge number of applications with this are possible to realize accurate. So these are all things what I think I'll stop here, Satish.
Yes, sir. Otherwise, you will take up to 720, sir.
Okay. I'll do that. Where I am there now. I'll show in that case some applications. So this is terrestrial laser VZ, this one. This is one type of laser, range is 600 meters. So it collects high speed and then continuously take that information. So this is the burst of, these are all the points where it collects. Entire region inside your defined window is scanned in minutes, accuracy in millimeters and centimeters. So these are all some of the examples of Dehradun. This is a Buddhist monk area. And then the profile is collected, and even to recreate three-dimensional building, and then also we can also say visualize and see that all those things he can do with a LiDAR. The cultural heritage. So there is a cultural department. Their requirement is to preserve our culture. Whatever the old buildings are there, they should not go means damage further. All those things they can do using a this terrestrial laser, and also see what are the bridges. All these things you collect the data from that, everything. Coming to spaceborne, there is a Chandrayaan. I think Chandrayaan also we have one this thing on LiDAR sensor, basically getting a profiles. So LLRI is a laser altimetry for Chandrayaan. Calypso for Calypso is one more satellite for the atmospheric studies, basically generating a wind profile and cloud and atmospheric details, and then modeling to the rainfall, etc. They are done. IceSat is one satellite for this ice, cloud, and land elevation studies. And Calypso is that in 2006 it is launched. It consists of 3 colligned nadir viewing instruments: cloud aerosol LiDAR, orthogonal polarization, image infrared radiometer, and then wide field camera. Another is IceSat, is that 2003 it is launched. So this is basically using a waveform. You send a beam, it selects a particular area, and then that particular is a bigger area. So you say it is a large footprint, 70 meter spaced. It collects 70 meters, and then it will leave some space in between, and then next 70-meter footprint is collected at 172 meters. So that means each range-wise it collects the data. So then it is basically used for tree segmentation, structure, and height estimation, etc. It is used. And then ISAT-2 is the latest, which is developed by NASA, launched in September 2018. So it meant to scientists 3D portrait of a global surface over a period of time that can prove to be instrumental in tracking changes in terrain, glaciers, sea ice, forest, cloud, and more. A much smaller laser beam illuminating surface of 10 meters. So it is very high resolution what I am talking. The beam of 10,000 times per second. The Atlas instrument has a precision of 800 points maybe second. And hence, with accurate like this, ISAT-2 can take measurements at every 70 centimeter, which is smaller footprint and a dense spatial sampling. So that means you get a higher profile, better profile this thing. Hence, we extract information of satellite location, time of the flight of the photons, and also direction of the laser pointing the distance to be calculated. So this is where it is collected, waveform, bone, LiDAR reflectance, and amplitude for urban landscape classification. So there is a aerial LiDAR. One more is a bathymetry. For civil engineers, bathymetry is also very important. So for bathymetry, you send a signal, it goes top of the surface of the water body and also bottom of the water body. Then based on the return, you will calculate the bottom of the return. But here, problem is when if it is a clear water, it works very well. But if it is a muddy water, then there is a problem. So the accuracy will be drastically reduced. So that is what we have to notice. For that, we use a echo sounder sonar based studies. So for bathymetry studies, that is now drones are also coming for that. So there are many other automation processes are going on. I think I'll stop here, Satish.
Okay, sir.
I think, yeah, I'll provide the slides.
Anil,
So, yeah, any questions?
No, sir. No
Then
questions
I'll
from
ask.
anyone.
No, then see, what are the different techniques used for getting the height of the ground? Anybody from the participants? I mentioned already, then you can just revisit. What are the different techniques used for collecting a three-dimensional profile of the ground? Somebody from the participants? Whatever you understand, you can tell.
LiDAR.
LiDAR is
technology.
one. Any other thing?
Like DEM, DTM.
Correct. Any other technology? What is that? Somebody may. What are other measurements? Like LiDAR is one, but LiDAR also. What are the different type of type collection? One is aerial, another is
Satellite.
yeah satellite. Third one
Ground LiDAR also is there.
terrestrial.
Terrestrial, yeah.
Another one water LiDAR, bathymetric. Okay, correct. Bathymetry also we can do. You understand bathymetry? What is bathymetry? People, anybody knows
Depth of
what
the
is
water.
bathymetry? Pardon? What is bathymetry?
To calculate the depth of the water zone.
Correct. Depth
The
of the water,
Two
profile of
ways
the
it goes
ground.
to on the surface and then also bottom. Then that gives the depth of thickness of water layer.
Yeah. Where this bathymetry is required?
Mostly seas, ocean.
Correct. Ship movement, boat movement. So they require exact
Yes, sir.
this thing.
Yes.
Yeah. Your ports and all, no, they do continuous bathymetric survey. So channel, no, otherwise the channel siltation takes place. Like then the boat will stuck in the silt. It will not able to move. So that means you remove the silt and create a route. Remove the sand and make the sufficient depth of the this thing. For that, the bathymetric survey is done continuously. Yeah, I think thank you all for joining this. So I'm sharing my slides to Satish. So he will help. He will give
Thank you, sir. Thank you very much.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you all for patiently listening. And yeah, anytime if somebody want to know many details, you can come through Satish or you can come to me directly also.
Thank you, sir. Thank you very much.
Yeah.
Thank you, sir, for
Thank you.
this
Thank you so much, sir.
lecture.
Yeah,
On this
Kushwaji,
hectic-
Yes, sir. Thank you so much, sir.
you know me. We are working together sometime earlier. Where are you now?
I'm in my hometown, sir. I will call you, sir. I will call you.
Okay, okay. Thank you.
Okay, sir. Thank you.
Thank you. Yeah. Yeah, all can leave. I think I'll just have a talk.
We had another session, sir.
Okay, okay. Please go ahead. I'll leave. I'll leave here. Yeah.
Yeah, okay, sir. Thank you, sir. In this hectic schedule, you have joined. So the next resource person is Mr. Funny. He is from United States of America and he is a professional engineer. So he'll be joining in another 5 to 10 minutes. So I hope we'll start by 7:35. Thank you. Mr. Funny, are you available?
Yes, I'm available now. Can you hear me?
Yeah. I can. Yeah, we'll wait for another 5 minutes. Okay.
Okay.